Think about your smartphone. It is a supercomputer that fits in your pocket. It has a high-definition screen, a powerful processor, and antennas that talk to space. But all of that incredible technology is useless without the silent, black brick hidden deep inside its chassis. We tend to treat that brick like a fuel tank. We fill it up at the wall and drain it throughout the day, as if electricity were a liquid pooling inside a bottle, just waiting to be poured out. If you were to cut a battery open, you wouldn't find a single spark or a glowing cloud of energy. Instead, you would find a messy, damp chemical sandwich. Inside that brick, we have created a controlled chemical time bomb, a state of extreme potential that we can trigger at will. To see how this works, we have to shrink down to the molecular level. Down here, everything operates on one absolute law of physics. The universe wants to be in balance. This diagram shows the two main sides inside every battery. On one side, we have the anode, usually made of lithium and carbon, which is packed with extra electrons it doesn't want. On the other side, we have the cathode, a complex metal oxide. The cathode is full of structural holes, essentially starving for those exact same electrons. These two sides are chemically desperate to interact. If they touched, they would react instantly, releasing all their energy in a single intense hot flash. The battery would die immediately, or explode. To prevent that, we place a microscopic gatekeeper between them called the separator. It allows tiny positively charged ions to pass through, but it acts as a total wall for electrons. The electrons are trapped on the anode side, staring at the cathode with no way through. The tug of war has begun, but the rope is permanently jammed. This physical barrier forces the battery into a state of intense chemical desperation. That tension is the true source of its trapped potential. This grid provides the sheer force required to overrule the laws of physics inside your pocket. By plugging in, you are leveraging this massive infrastructure to act as a microscopic dictator, physically driving the battery's chemistry out of its natural equilibrium. The electricity from your wall charger flows in and pushes the lithium ions and electrons away from the cathode, trapping them onto the anode. It is the microscopic equivalent of rolling a massive boulder up a steep hill. When your screen reads 100%, the anode is packed to its limit. It is a high-pressure, overcrowded room of trapped electrons pushing against the separator, desperately looking for a path back to the empty cathode. We call this extreme, forced state of imbalance stored energy. We are holding the universe in artificial tension until the moment we demand its release. The moment you tap your screen, a switch flips. You create a bypass bridge, allowing the trapped electrons to finally sprint toward the cathode. This image shows the complex, labyrinthine pathways of a microchip. We refuse to give the electrons a straight path home. Instead, we force them to push through tiny transistors to illuminate your screen and vibrate your speaker along the way. As the electrons take that long journey through the external wire, the positively charged lithium ions inside the battery swim through the separator to meet them. The tension begins to release. The boulder rolls back down the hill. The tug of war ends only when the anode is completely empty and the cathode is full. At that point, the battery is dead. The electricity running your device is simply the mechanical byproduct of millions of electrons desperately rushing home to restore universal balance. You plug it back in to repeat the cycle, but this microscopic violence has a cost. Over time, some lithium ions get permanently trapped inside the separator. Under the extreme stress of this forced movement, the delicate internal layers of silicon and carbon begin to crack and degrade. This structural breakdown is why your phone's battery life shortens significantly after a year or two of use. The internal storage tank is physically breaking apart, making the hill smaller every time you climb it. We have learned to bottle the fundamental forces of the universe, releasing them one electron at a time to power our lives. That low battery warning is just a signal that the tension has finally resolved and the electrons are going home.